Hey kids, Charlie Busso here. We're going to do bonding notes, page 10. All right, dot diagrams, structural diagrams. We're going to draw a quick. C2H6 is going to look like this. Carbon has 4 dots. This carbon is going to have 4 dots. So there's going to be a single bond in the middle. And then we're going to have a hydrogen, and a hydrogen. And over here, we're going to have another hydrogen, and another hydrogen. It's going to look like this. The C to C bond and the H to C bond. This is going to be single, non-polar, covalent. And this is going to be single, polar, covalent. So there's 2 kinds of bonds. Now there's a total of 1, 2, 3, 4, 5, 6, 7 bonds. One of them is like this, and 6 of them are like that. In this next one, carbon is going to make a double bond to carbon. And then we're going to put a hydrogen up here and a hydrogen up here. Another hydrogen up here and another hydrogen over here. It's going to look like this. See, I changed that angle. Instead of being 90, I made it a little more fishtaily. That's kind of just cool because I'm cool. We're going to have 1 carbon to carbon, which is going to be a double nonpolar covalent. And then we're going to have 4 HC bonds. Those are single polar covalent. All right, C2H2. I know that hydrogen is going to bond to carbon that way. And then another carbon is going to jump in and bond that way. HC triple bond C. So we have 1 CC. This is a triple nonpolar covalent bond. And then we're going to have 2 HC bonds, which are single polar covalent again. C3H8, now we're just getting bigger. Carbon, I'm going to put in all the dots at once because I know what I'm doing. Carbon, 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 hydrogens on the end, and then above and below, we have more hydrogens. So we have 8 hydrogen carbon bonds, which are single polar covalent. And then we're going to have 2 carbon to carbon bonds. In this case, they are single nonpolar covalent. Carbon to carbon, carbon to carbon. Now, the reason they're nonpolar versus polar, carbon and carbon both have the same electronegativity value. Carbon and hydrogen have different electronegativity values. So the carbon-hydrogen bonds are polar, and the carbon-carbon bonds are nonpolar. Here, they share 1 pair of electrons, so it's single. Here, they share a triple bond, or 3 pairs of electrons, triple. Here, they share 2 pairs of electrons, and it's a double. Carbon dioxide, you're supposed to memorize. I'm going to use 2 different colors. There's my oxygen. It has 6 dots. Here's my carbon. It has 4 dots. And here's another oxygen on the other side. And it's going to look like this. Straight line. Now, there's 2 bonds, oxygen to carbon. It's a double polar covalent bond. 2 of them. AsCl3. Now, arsenic, let's take the periodic table out because I know this, but I don't know that you know this. Let's see where arsenic is before we get too crazy. Arsenic is right here. What's it under? Nitrogen, phosphorus, arsenic. Look at this electron configuration. 2-5, 2-8, 2-8-18-5. They all end with 5. They all have the same sort of combination. So arsenic is going to have 5 dots. And just like nitrogen and phosphorus, there's a pair and 3 singles. And then the chlorines are going to come in like this. This chlorine has a total of 7 dots. This chlorine has a total of 7 dots. And this chlorine has a total of 7 dots. So we have AsCl, Cl, Cl. And the Cl to As bond, we're going to have to look up the electronegativities, and we never assume anything because there's always quirky things going on. Arsenic is 2.2, chlorine is 3.2, so we have 3 single polar covalent bonds. C4H10, remember this one we did before? C4H10, there's just a lot more dots, and I'm not even going to draw them because there's too many. This is the 4 carbons, single bonded, and here are the 10 hydrogens. They go all the way around the outside. So now we have 10 carbon hydrogen bonds, which over and over are single polar covalent. And we're going to have 1, 2, 3 carbon to carbon bonds, which are single non-polar covalent bonds. So this molecule's got 13 separate bonds. This looks like this with all the dots, but you know what? You got to be crazy to draw that. You know how many dots that is? Too many for me. OBR2. Now, when you have H2O, oxygen and 2, here oxygen's in front, but it's in a 1-to-2 ratio, the oxygen is going to make 2 bonds, like that. The bromine's going to come in here and here. This bromine has 7 dots, and this bromine has 7 dots. And it's going to be O, Br, Br. And O is a 3.4 and Br is 3.0. So we have 2 single polar covalent bonds. 2 bonds, 3 atoms, the whole molecule. And then CCl4, carbon is going to have 4 dots for 4 valence electrons. Chlorine, 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 and chlorine. All right, I'll draw this, but oh my gosh, there's so many dots. I'm getting a little crazy. See, the reason I'm getting crazy is because I kind of know this well enough. I don't need to do all these dots anymore because I really get it. This is what it does. Look how easy this is. Boom, I'm done. And the chlorine to carbon bond is going to be single polar covalent, and there's 4 of them. This was page 10 in the notes.